Hi, hello, welcome to our channel. So in this video we will learn about PMMC instrument, so which is important in our examination. So this PMMC instrument means permanent magnet moving coil instrument. So this PMMC instrument measures only DC quantities, that is either voltage or current. So if you want this PMMC instrument, uh, PMMC instrument perfectly drawing this diagram, we can easily write down the construction and working of this PMMC instrument. So first you draw the perfectly this diagram. So by observing this, we can write construction and working of this instrument. So PMMC instrument. So first principle. What is the principle? So whenever a current carrying conductor placed in a magnetic field, a mechanical force acts on the conductor. That means a motor principle. A current carrying conductor placed in a magnetic field, force acts on the conductor. So this is the principle. Motor principle పైన ఆధారపడి ఈ PMMC ఇన్స్ట్రుమెంట్ అనేది వర్క్ అవుతుంది అన్నమాట. సో ఫస్ట్ కమింగ్ టు ద కన్స్ట్రక్షన్. సో ఈ కన్స్ట్రక్షన్ వచ్చేసి బై అబ్జర్వింగ్ దిస్ ఓన్లీ వీ కెన్ రైట్ ద point by point. So first it has a permanent magnet. So ప్రిన్సిపల్ ఏంటి, మన ఫోర్స్ అనేది యాక్ట్ అవ్వాలి, ఫోర్స్ అనేది ఇండ్యూస్ అవ్వాలి. సో ఫర్ దట్ వీ నీడ్ ఎ magnetic field and a current carrying conductor. So in this permanent magnet moving coil instrument, magnetic field is constant and current carrying conductor is rotating. So magnetic field is constant, here it is. So this PMMC has a permanent magnet and a rectangular moving coil and a permanent magnet. And this permanent magnet has two U-shaped soft iron poles, north and south poles are U-shaped and are of soft iron. Next, a rectangular coil of many turns is wound of fine wire is wound on a aluminium former, inside which an iron core. Okay, so it has a magnetic permanent magnet, and that magnet has two U-shaped soft iron magnet poles. So in between these two U-shaped magnetic poles, so a rectangular coil of many turns is wound on the aluminium former, inside which a cylindrical iron core is mounted. Okay, so see, the coil means here is shaded part of here. It is a coil wound. This is a coil, and this coil is attached to the spindle. This coil is attached to the spindle, and this spindle is pivoted between the jewel bearings, and it is in such a way that it rotates freely between the pole pieces. Okay, this coil is attached to the spindle, and the spindle is pivoted between jewel bearings in such a way that it rotates freely between pole pieces. Okay, and next, two hair spherical springs of Pasper branch are mounted on spindle. One is above the coil and another one is below the coil. And these two springs serves two purposes. So one is current in and current out of the coil, and another one is provides controlling torque. So controlling torque is to control the deflections. Okay, so here controlling torque is provided, and damping torque. How damping torque is provided? So in this PMMC instrument, damping torque is provided by eddy currents induced in this aluminium form. So this is all about construction. And coming to the working. So coming to working, So principle. So principle. What is the principle? Current carrying conductor placed in a magnetic field. Placed in a magnetic field. Force acts on that conductor. So for that, what we have first, what we want, current carrying. So what is the purpose of this instrument? So this instrument is used to measure either voltage or current, right? So when you want to measure either voltage or current in a circuit, so first you want to connect this instrument to the circuit, and when you switch on the circuit, then the operating current flows through the coil. Okay, so the operating current is flowing through the coil, and this current carrying conductor is placed in a magnetic field, and force acts on this conductor. Okay, so this force acts on this conductor, causes moment in this coil. Okay, so thereby this coil is connected to the spindle, and this is free to move. Okay, and what are the parts connected to this spindle also rotates. That means the moment in this coil causes rotation in the pointer. That means the pointer starts deflection. Okay, so over a scale, so it has to deflect. Okay, so the pointer deflects, and when the coil moves, the springs are twisted or rewound. Thereby, they offer a controlling torque. That controlling torque controls this deflections of pointer. Okay, so here deflecting torque is produced. That deflecting torque produced, TD, is directly proportional to the operating current. The deflecting torque TD is directly proportional to the operating current. So how much quantity of current we are flowing, so that much amount of deflecting torque produced. Okay, and controlling torque. Controlling torque is directly proportional to the deflections. When this deflecting torque is equal to the controlling torque, then the pointer comes to its rest position. That means it reaches its final position. That is theta, TD equals to TC. Theta is directly proportional to operating current I. Okay, so final aim of this instrument is, so it has to read either 3 amperes or 4 amperes, how much current flowing in this, so that has to read here. Okay, so when controlling torque is equals to the deflecting torque, and the pointer stops, it hits the final position or rest position when controlling torque is equals to the deflecting torque. Okay, and that deflecting torque equation, so that deflecting torque TD. Okay, so this works. So if you want the equation, so the deflecting torque TD is, so according to Fleming's left hand, so this is represents induced force developed, and this pointing finger represents direction of the magnetic field, and this middle finger represents direction of the direction of the current. So thumb indicates a direction of developed force, direction of the force, and this is direction of magnetic field, direction of current. So this in developed force is opposite to the direction of the magnetic field and direction of the current. Then the deflecting torque TD is equals to BLI into sin theta. Here theta is 90 degrees. Why? Because, so according to Fleming's left hand rule, so this developed torque or force is perpendicular to the direction of the magnetic field and current. So here L is length of the coil. L is length of coil, B is flux density in Weber per meter square or Tesla, and I is current in amperes, and theta is deflecting oil angle, deflecting angle, theta is deflecting angle. The force developed F. The force developed F is equals to BL into I sin theta. But the torque developed is nothing but force into distance. So what is the force? BL I into B. So here theta is 90 degrees. That means F is equals to B into L into I. But torque, deflecting torque TD is equals to F into force into distance. So TD is equals to B into L into I into B. So which is equals to B into I into B into I into L into B. So where this B is width of coil, so it is B into I into L into B, nothing but A. So this is T in one turn, and this coil has n number of turns. So the torque developed in the total coil is N into B into I into A Newton meter, where N is number of turns of coil. So this is the deflecting torque produced in the PMMC instrument. So the deflection in the PMMC instrument is directly proportional to the current, I. So the scale in PMMC instrument is uniform. The scale in PMMC instrument is uniform. Okay, so only by observing the diagram of PMMC instrument, so we can write down easily point by point its construction and working. See, so point by point we can write by observing the diagram. Okay, thank you.